Welcome, everyone. We are going to move along here and continue our investigation of categorical logic. In this video, we're going to do a little bit of review of some of the ideas we've explored in previous sections, and then we're going to move forward and introduce a new tool that we will use to kind of apply some of the ideas regarding categorical logic to discover the truth value of certain propositions. Okay, so just to kind of cover our lesson plan here, somewhat formally, um, we are going to do a review of our four types of categorical proposition. Again, this is a skill-based class, so the more you can write down these categories and commit them to memory, the better you will be. All right, so as we're moving along here, I do encourage you to write down the categories and the accompanying notation. We're then going to begin to learn what are called immediate inferences. And if you recall from our first sections, an inference is that part of an argument that has to do with the movement from premises to conclusions, or the logical process of reasoning underlying a conclusion, why we should believe a particular conclusion in relation to premises. So there are going to be some rules we can pick up here regarding the structure of the types of categories of sentence that allow us to determine whether or not a related proposition is true or false just by virtue of the relationship. All right, so that's very abstract. I'll have to show you exactly what I mean, but immediate inferences are inferences that move directly from one sentence to another. And the tool we're going to explore to get a grip on immediate inferences is known as the square of opposition. The square of opposition is a very handy tool that gives us kind of a visual diagram of the relationship of inferences that we're allowed to make with categorical propositions. All right, so I'll have to show you what that square is and what the moves are, as it were, that we're allowed to make. So let's do a little bit of review before introducing the new topic. Remember, we have our four categories of proposition. And that first category is our A proposition. The A proposition is a universal affirmative. Universal affirmative propositions take the form all SRP. And remember, we're using S to stand in for the subject class and P to stand in for the predicate class. Remember that categorical logic is dealing with classes of things, and the structure of the sentence separates subject terms from predicate terms with the copula, the verb to be, in this case, are, right? This is universal because the subject group is referring to every member of the class, all S, RP, and the quality of the proposition is affirmative because we really are including membership of the S class in the P class. The second structure of categorical proposition, the second type, is the E proposition, which is going to be our universal negative. Universal negative takes the form for any content, no SRP, no SRP. This is still universal because the quantity S is universal. It's referring to every member, or in this case, not every member. There is total exclusion of the S class from the P class. And the quality is negative because we are denying membership of S from P. So we have our A and we have our E. We then have our I proposition. The I proposition takes us into the particular for quantity. I proposition is our particular affirmative. The particular affirmative in standard form is some SRP. This is true for any content. Where we have affirmation, the quality is affirmation of at least one member of the subject group as being included in the predicate group. So it's not universal because it's not saying every S and it's not saying all S. It's just saying some. So all we know is that there is at least one S that is a P. And so therefore, this is a particular statement, not a universal statement. We then have our O proposition, which is going to be our particular negative. category. And the O proposition for any content takes the form some S are not P. Some S are not P. So our quantity is particularity and our quality is negation, is negative. We're denying membership of the S in the P class. So A, E, I, and O are for categories, and the good news is that that's really the full set, as it were, in categorical logic that we're going to be exploring. Once you've committed these to memory and have an understanding of the relationship of S to P in each one, you'll be in very good shape for moving forward with the subsequent problems. Okay, so let's do a little bit of review of some of these concepts. We have quantity. I was just mentioning this. Quantity refers to the how much of the class terms. Is this universal or is it particular, right? If our S group is being described with terms like all or every, the how much is universal. But if it's some or a few or this kind of language, it's got to be particular. Indicators are all, none, and some. We then have, as an example, a sentence like this: all elephants are animals with powerful memories. All elephants are animals with powerful memories. So just try to write down for yourself, what is the quantity of this sentence? What is the quantity? This is a universal. If you wrote down universal, you are correct. And this is an A proposition, right? This takes the form all SRP. We're including the class term subject, elephants, in the predicate class term, animals with powerful memories, right? So sometimes, you'll have to be aware of the fact that our S class is kind of lengthy, right? This entire term, animals with powerful memories, can count as our P group. And this is our S group, elephants. And then we have our copula, R, separating the subject from the predicate. Okay? What is quality? Quality refers to really the relationship of the class term subject and predicate. Qualities can take the form of affirmation or negation. Affirmation, really, I like to think of it as inclusion, and negation can be thought of as exclusion. So it refers to the relationship between the subject term and the predicate term. You can have a universal affirmative, right, in which everything is included, but you can also have a universal negative, the E proposition, no SRP, in which the subject is totally excluded from the P group, right? So it cuts both ways, as it were. The universal can be either affirmative or negative, and the particular quantity can be either affirmative or negative. Let's look at an example here. Some buildings are skyscrapers. Some buildings are skyscrapers. Try to write down for yourself, what is the quality of this sentence? Some buildings are skyscrapers. If you wrote down affirmation, you are correct. This is our I proposition, right? This is a particular affirmative because our subject class buildings is coming with this indicator word some. So we know this is a particular, right? And we have our predicate group over here. So this is affirmative, separated by the copula are. How about this sentence? All buildings are not landscapes. All buildings are not landscapes. This is a negative sentence, right? We're having total exclusion. Now, this is actually not in standard form. And the equivalent of this sentence is an E proposition, right? E proposition takes the form no SRP. No SRP. And really, if we think about it, this would be equivalent in meaning. If I say all buildings are not landscapes, what I'm really saying is no buildings are landscapes. So be aware of that fact. There's a kind of peculiarity of English such that E propositions can look like this. All buildings are not landscapes. But really it's not in standard form until we put it into this structure of no SRP. But this is a negative sentence. That's really what I'm trying to emphasize here. We have negation, and universality is our quantity. Let's look again at distribution. This is sort of a tricky component of categorical logic, and it has to do with the relationship of subject to predicate. Remember that for the A proposition, or universal affirmative propositions, we have subject terms that are distributed but undistributed predicate terms. If you recall from our previous video, distribution means that if a term is distributed, that every member of the class is said to be sort of definitively known as belonging or not belonging to another, right? So in this case, the subject term is distributed because we really do know that every member of the subject group is also a member of the predicate group. However, the meaning of the sentence is such that it's not going the other way. We don't know that every member of the predicate class is also a member of the subject class, and so the predicate term is said to be undistributed. For our E proposition, our universal negative, we have total distribution. We have distribution of the subject term and distribution of the predicate term. And that's because we know definitively that no member of the S group is also a member of the P group, and no member of the P group is also a member of the S group. So E terms, E propositions are totally distributed, going back and forth. We have no distribution, however, for our particular affirmative propositions, for our I propositions, right? Because we don't really know definitively the membership of every member of the subject group in the predicate group. We only know at least one member of the subject group belonging to the predicate group. We can't say that the subject class term is distributed, and we don't know anything really about the membership of the predicate term in the S group. So there is no distribution for our particular affirmative statements. For our particular negative statements, our O propositions, we have undistributed subject terms but distributed predicate terms. We don't know about the in total membership of the S group in the P group. We just know that there is at least one member of the S class that is also a member of the P class, but not an exhaustive inclusion. However, we do know that there is at least for sure one P that is not an S. So we have distribution in the predicate class term. So again, I'm not asking you to memorize the shorthand as though it's something you have to reproduce on an exam verbatim. It's just very useful, I think, to begin to understand the structure, the formal structure of these categories of proposition and how the terms are relating to one another in terms of affirmation or negation, right? And that's really what we're after. So universals distribute the subject term across the board, right? We have distribution for subject terms in both A and E, but the negatives distribute the predicate term across the board, right? We have distribution for the E, which is negative in quality, and then we have distribution of the P for the O proposition, which is negative in quality as well. So it's a kind of an interesting property of distribution for our four types. Okay, so try to make sure you have at least a passing understanding of distribution as we move forward here and as you're doing the work of memorizing the four types of proposition. Okay, now let's talk about the square of opposition, and this appears in section 5D of the Baronet textbook. Opposition has a technical definition that I'm just going to read here, but again, I don't think you'll really get a sense for what I mean here until we actually work with the square. But the definition is when two standard form categorical propositions refer to the same subject and predicate classes, but differ in the quality, quantity, or both. Okay, so opposition refers to two sentences that both of them take a standard form, right? And there could be differences amongst their subjects and predicates, as well as their quantity and quality, but they are two of them, and they're both standard form. Okay, then we have opposition of some kind or another. There are different kinds of opposition that we're going to have to study and unpack a little bit further to see what kinds of inferences we can make on the basis of their relation. Now, there are 4 types of opposition that allow us to make inferences on the square of opposition. The first type is known as contradictories. 2 sentences could be said to be contradictory. The second type is known as contraries. 2 sentences could be in a relationship of contrariety. The third is known as subcontraries. And the fourth is subalternation. Contradictories, contraries, subcontraries, and subalternation. Okay, so in this video, we're just going to have a look at the first 2, contradictories and contraries, and then in the next video, I'll walk you through the meaning of subcontraries and subalternation. All right, but write these 4 down for now, and also check back on your book for the technical definition. So let's have a look at what contradiction means. We probably have an understanding of the meaning of contradiction in everyday life. Contradiction usually means something like conflict or opposition. Usually we mean that sentences are contradictory if they both can't be true, right? And that's pretty close to what they mean here in formal logic. In categorical logic, contradictories are pairs of propositions in which one is the negation of the other. And if one is really the negation of the other, it means that one is true and the other is false. They have opposite or conflicting truth values. Contradictories are 2 sentences of categorical standard form that have opposing truth values. Okay, so we're going to have to learn which ones are contradictory and why. So let's have a look at examples of sentences that are said to be contradictory. For every sentence in the universe that is an A proposition and an O proposition, regardless of content, those sentences are said to be contradictory. They have a contradictory structure. A and O propositions are always contradictory. That means that if an A proposition is true, the O proposition has to be false. If an O proposition is false, its related A proposition has to be true. All right, so let's see how this looks a little bit. If we have a sentence like this, all zoos are places where animals are treated humanely. This is an A proposition, right? This is a universal proposition where we have universal affirmation. We're saying all zoos, all is our indicator word and zoos is our subject. And then our predicate is this kind of lengthy term, places where animals are treated humanely. So we have an A proposition here in the first sentence. And then the contradictory of that sentence, if we're to think about how to transform that sentence into its contradictory, we know it has to become an O proposition. We transform it into an O. So the universal becomes a particular in the O proposition, some, and the quality becomes moves from affirmation to negation with are not. So the O proposition is some zoos are not places where animals are treated humanely. So if I know that the A proposition is true, all zoos are places where animals are treated humanely, and we could debate about whether or not that's actually accurate, but let's just assume for the sake of argument right now that the A proposition is true. This means that by necessity, the O proposition is false, because it can't both be the case that all zoos are places where animals are treated humanely, and simultaneously, some zoos are not places where animals are treated humanely, right? So if the A is true, the O has to be false. However, if the A proposition is true, it's not the case that all zoos are places where animals are treated humanely. Then it has to be the case that the O proposition is true. Some zoos are not places where animals are treated humanely would become a proposition with a true value. Okay, so um, try not to think so much about the empirical content here again of the premises, but just try to think about the transformation and the relationship of A to O as being a relationship of contradiction with opposing truth values. Okay, so that is the first set of categories that are in a relationship of contradiction. We then have another set of sentences that are always contradictory. E and I propositions are always contradictory. Remember, the E proposition is our universal negative, no SRP, and our I proposition is our particular affirmative proposition, some SRP. So it can't be the case that both an E proposition and its related I proposition are true at the same time. If the E proposition is true, then the I proposition has to be false. If the I proposition is true, then the E proposition has to be false. So let's look at our examples here. If we have an E proposition like this, no zoos are places where animals are treated humanely. This is an E proposition because we have our universal quantity and then our subject zoos with our predicate places where animals are treated humanely. This is quantity is universal and quality is negative. This is an I proposition. Some zoos are places where animals are treated humanely, right? So we have our particular affirmative here. So if this sentence, its value is true, it really is the case that no zoos are places where animals are treated humanely, then the I cannot possibly be true too. It has to have a false value. There can't be at least one zoo that is also a place where animals are treated humanely if we've already said that no zoos are places where animals are treated humanely. If, however, we're going to say the I proposition is true, there is at least one zoo that is a place where animals are treated humanely, then the E proposition has to have a false value. No zoos are places where animals are treated humanely can't logically be true if we take for granted the I proposition as being true. Okay, so contradiction means that true and false are opposed, or rather, I should say, that the opposing sentences can't both be true at the same time. If one is true, the contradictory sentence has to be false, and vice versa. Okay, so contradiction is a very important logical property of categorical propositions. It'll allow us to make a lot of inferences from just single sentences, right? Just based on the value of that sentence and the type of category of sentence it is. Because as you can see, we can kind of transform sentences into their opposite, right? We can turn this E proposition into an I proposition if we want, right? Just by changing the quantity and the quality of the sentence, right? So these relations of opposition allow us to sort of tweak our proposition in order to explore a little bit more the relationship or really the truth value that might be inhering between the sentences. Okay, so here is the visualization of the diagram of the square of opposition for our contradictions. Now there are two types of square, modern and traditional. I'm just going to talk about the modern square for now. And please refer back to this in your book if you need to. I'm also going to post it on the PowerPoint here so you can look back on it. The square of opposition tries to break down all the four types of category in terms of a placement that allows us to sort of visualize these relations of opposition to one another. So we're always going to be putting our A propositions up here in the lower left, our universal affirmative proposition, all S or P, is up here. Then we move over to the right for our universal negative, no S or P. So notice that we have our universals. I'm just going to try to write this up here on the top of the square. Okay. And then we move down the square, and you will notice in the lower left, our I propositions. Our I propositions are our particular affirmative, some SRP, and then we move over to the right, our O propositions are particular negatives, some S are not P. So notice what these arrows are indicating. We're indicating the relationship of the A proposition to the O proposition because A and O are always contradictory to one another. If an A proposition is true, then its contradictory O proposition has to be false, right? And notice that E stands in a relation of contradiction to I. So if an E proposition is true, then the I proposition has to be false. And likewise, if an I proposition is true, the E proposition has to be false. That is an immediate inference that we are allowed to make every time we have two propositions that are standing in this contradictory relationship, A to O and E to I. All right, it's a move that we're allowed to make. So for any sentence in the world that takes the form of the A proposition, we know that if it's true, that its contradictory O proposition is false. And likewise, for any sentence in the world that takes the standard form E proposition, if it's true, we know that the contradictory I proposition is false. All right, so that's a very neat kind of maneuver we're allowed to make that allows us to make all kinds of inferences on the basis of very limited information about the sentence, right? Okay, so please, if you haven't already, draw this square of opposition and make sure you write our letters in this exact arrangement. A on the upper left, E on the upper right, I in the lower left, and O in the lower right. And then do draw out the arrows that indicate contradictories, A to O and E to I. Don't worry so much about the distribution notation here. This is just repeating that information we went over about whether or not the subject and predicate terms are distributed or undistributed, depending on the category of proposition. All right, this map has kind of a lot of information here. I just want you to have a sense for the square and the relationship of contradiction for now. Okay, moving along here. Now I want to look at the next set of oppositions, known as contraries. Contraries are very similar to contradictories, but there's a slight difference in meaning and a slight difference in their arrangement on the square of opposition. Okay, contraries are said to be pairs of oppositions that cannot both be true at the same time, but can both be false at the same time. All right, so this gets a little confusing for students, I think, because we've just learned contradiction. Contraries kind of sounds like contradiction, and its meaning is very close to contradiction, but there's a little bit less certitude with respect to the inference of the truth value. Okay, so let's have a look at which categories of proposition are contradictory. A and E propositions are contradictory. So our universal affirmative and our universal negative propositions stand in a relationship of contrariety to one another. All right. So if an A proposition, if an A and E proposition is false, we don't know anything about the truth value if the A proposition is false, we don't know anything about the truth value of the E proposition. And similarly, if an E proposition is false, we don't know anything about the truth value of the corresponding A proposition. Okay, so you can't move from a false contrariety to knowledge of the truth value of its opposite pair. All right, so let's try to break this down a little bit. That's a little abstract. If I have a sentence like this, just look at the first set on the left here. Uh, no squares are circles. Okay, let's say that that sentence is true. Um, this is I hope you can tell by now an E proposition, right? This is a universal negative, and the E proposition, its contrary, is an A proposition. So the E, its contrary, becomes all squares are circles, right? This sentence is the transformed universal affirmative version of no squares are circles. If we begin with a true E proposition, we can infer that its contrary is false. We can move from a true E to a false A. So on the square of opposition, we can move from E to A if the first value is true. Similarly, let's look at this sentence. All guitars are stringed instruments. Again, this is an A proposition. This is a universal affirmative. We're saying all guitars really belong to this predicate. Stringed instruments, right? This is the predicate. If this value is true, then we can similarly infer that the contrary, the E proposition, no guitars are stringed instruments, is false, right? There's probably a common intuition uh, leap of inference you can make about that. If we're saying all guitars are stringed instruments, that's true. Well, it can't be the case that no guitars are stringed instruments, right? So that's a move you can make on the square of opposition. The contrary allows you to move from a true contrary to a false contrary, but not the other way around. We can't begin with a false, no guitars are stringed instruments, and infer the A proposition, all guitars are stringed instruments. Similarly, if we begin with a false, all squares are circles, we don't know that the corresponding E proposition is true. Okay, the value is said to be undetermined. We'll talk a little bit more about when a proposition is undetermined, but suffice it to say for now that it means we don't have enough information to make that inference. So let's try to clarify this a little bit. I know that's kind of a tricky point, but if we turn back to the square of opposition, we look at the contraries. The contraries appear here on the top. A and E are contraries, where our A is our no SRP, right? Excuse me, all SRP. My writing's not too good. And then our E is no SRP. So if I begin with a true A proposition, I can infer that the contrary, the E, is false. That is a move I'm allowed to make on the square of opposition. However, if I begin with a true A, a false A, all SRP is false, I can't make the inference about the E group. The E group is said to be undetermined. Please excuse my writing. Undetermined. Unknown. Okay? Now, I also want to indicate to you uh, that we're going to be looking at the I and O. These are known as subcontraries, okay? And they take a kind of similar form with opposed values. But so far, I just want to kind of recap where we're at. We have our four types of categories: A, E, I, and O, universal affirmative, universal negative, particular affirmative, and particular negative. We have two kinds of opposition contradiction, which is A and O, and E and I. And then we have our relationship of contraries, A and E. A and O take completely opposed truth values. If A is true, O has to be false. If O is true, A has to be false. Contraries have a similar truth value, but slightly less definite. If a true value is contrary, we can infer that its contrariety is false, but if it begins with a false proposition, the contrary proposition is undetermined. It's unknown. It's not an inference that is allowed. So please just try to practice repeating the square of opposition. Write down your 4 types of proposition and draw the square of opposition with the relation of contradiction and contraries built in there, so we can start to get in the habit of memorizing the square. Okay, in the next video we will talk about the next 2 types of opposition, subcontraries and subalterns. All right, thank you everyone. I will see you next time.